In this video, I'm planning to explain the permutation with identical elements, which means if there are same elements in the set, in how many different way we can arrange the things. Shortly, we can say like that. As you see in Skopje, the word in Skopje, we have 6 different letters, and each of them they are different. That's why we can arrange this 6 factorial different way. But for Tetovo, we cannot say the same thing, because in Tetovo there are T's and O's, and these are identical. So this should be, we have another formula for that one, this should be 6 factorial over 2 factorial times 2 factorial is going to be, where 2 factorial, because the arrangement between the T's is not important and arrangement between the O's is not important. What I mean, when we write the word Tetovo, if I write this one with blue color and Tetovo, if I write like this, and here when you read this one, it is Tetovo. Or if I write like this, here, again it's going to be Tetovo. But we switch the places of the T's. 2 T's there are. How many different way we can switch their places? 2 factorial different we can switch their places, change their places. That's why we are dividing by 2 factorial for T's and 2 factorial for the O's. So how many identical letter or thing there are, we should divide by the number of factorial of that identical thing is going to be. Okay, now let's see another example. As you see in Barcelona, we don't have any identical element. All the letters are different. We have A here. A's are common, so there are totally 9 different letters. 9 letters there are, and 2 of them they are same. So we are going to divide by 2 factorial, and this 2 factorial represent the arrangement between the A's is not important, because when you switch this A and this A, if you read the sentence again, it's going to be same or word. Okay, we are going to continue with Ferrari. In Ferrari, we have 3 R's. So totally 7 letters there are. So 7 letter words can be arranged with 7 factorial different way. And 3 R's we have here. So 3 factorial different way it's going to be. Okay, then taklamakan. Taklamakan is 10 letter word. So it's going to be 10 factorial over. Which letters are same? A's are same here, A, and A. So there are 4 A's, so 4 factorial different way we can arrange this A's, and it is not important for us because they are same letters. Then we have K's. Here we have K here and one more K here, so there are 2 K's here and 2 factorial different way we can arrange them. Again, I'm writing 4 factorial different way A's, and 2 factorial different way we can arrange the case, and this arrangement is not important. Okay, let's continue with the here. In this question we have 3 identical red cars, 4 identical blue cars, and 2 identical white cars, which means we can arrange like this: R, blue, and blue when I write, and white and white when I write. These letters, when I write the capital letters here, as you see, we have 9 letter word, and I'm going to arrange here the 9 letters. At the same time, we can arrange the places of the 9 different identical car. So arrangement between the capital letters here and arrangement between the cars, it's going to be same. And here, as you see, there are 9 letters, but R's are same, B's are same, and W's are same here. So 9 factorial, we are going to write at the beginning. This is going to be because of 9 letters that are here. Then we have 3 R's, pardon. So 3 factorial, different way we can arrange them, and this is not important in this arrangement, and this is going to be 4 factorial, and this is going to be 2 factorial is going to be. And if we simplify this one, 9 times 8 times, okay, 9 times 8 times 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial times 2 is going to be 2 times 1. 4 factorial, 4 factorial. We may simplify 3 and 6, it's going to be 2. 2 and 2, it's going to be equal to 1 and 1 here. And 2 and 8, if we simplify, this is going to be 4. So 9 times 7, 63. 63 times 226 times 5, 1260. Different way we can arrange this 9 cars. Okay. Yes. We are going to toss the coin 7 times, and we are looking for heads or tails. So we are going to write 4 heads, and we are going to write 3 tails. So when I write like this, it becomes 7-letter word, and 7-letter word we can arrange 7 factorial over 4 factorial times 3 factorial, different way, and it's going to be 7 times 6 times 5 times 4 factorial over 4 factorial times 3 times 2 times 1. Here, if you simplify this 2, 3 and 6, it's going to be 2. This 2 and this one, we are going to simplify. The answer is going to be 7 times 5 times 4, which is 35 times 4, is going to be 143. Is going to be. Every day Lazar walks from his house to school, and while he's walking his school, he should use these grid lines here, and 5 times he needs to go east, and 3 times he needs to go to north. So 5 times east he should use, and 3 times north he should use, and he should follow the path like this, and he will get the school. If you want, we can draw one example here. We can draw only one example. Let's say here 1 north, then 1 east, 1 north, 1 east, 1 north, 1 east, 1 north, east, and east it's going to be. If we count again here, it's going to be east, north, let me use different color for this one. Again, I'm repeating the things that I said. East, then north, then east, then north, then east, then north. And for the last 2 here, 2 times east again. As you see, this is one type of arrangement of the 5E and 3 N's in this table. And as you see, we can use this one 8 factorial over 5 factorial times 3 factorial, different way, which is equal to 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2 times 1, which is equal to, here it's going to be 3 and 6, 2 here, 2 and 2 is going to be equal to 1, and it's going to be equal to 56. Okay, then